Welcome back. Let's look at another problem, a prioritization or sequencing problem using Johnson's rule. A book binder company has one printing machine and one binding machine. There are manuscripts of a number of different books. Processing times for printing and binding are given in the following table. So the time is in hours, okay, and you have these books that have to be printed and bounded. Okay, they have to be printed and bounded in. They have to be printed and bound in these two machines, M1 and M2. Let's call them M1 and M2. So we have to sequence these jobs. You have 5 books A, B, C, D, and E. These has to be processed through these two machines, M1 and M2. Now determine the sequence in which books should be processed on the machine so that the total time required is minimized. Okay, so what is the rule, Johnson's rule? You always look at the total, the job with that takes the least amount of time to complete. So amongst A, B, C, D, and E, which job takes the least amount of time to complete and in which machine? Yes, B takes the least amount of time, 1 hour. In which machine? M1. So that has to be placed first. Now suppose the job takes the least amount of time in M2, then the rule according to Johnson is that that job has to be placed last. But since B has the least amount of time, okay, and that occurs in M1, that should be placed first. So B will be placed first. All right, so we are done with B. Ignore B. Now from A, C, D, and E, which job takes the least amount of time? A, it takes 2 hours. And in which machine? Machine 2. So A takes 2 hours in machine 2. Alright, so we have to place that as last. Always remember, if a job takes the least amount of time in machine 2, it should be placed last. So we are done with A. So A, B done. Now C, D, and E. Now from C, D, and E, which job takes the least amount of time? Yes, it is D, and D takes the least amount of time in in M1, so it has to be placed first. But since first place has been taken over by B, we place D as second. Okay, so we are done with A, B, and D. So finally we're left with C and E. Now between C and E, which job takes the least amount of time? Yes, it is E. E takes the least amount of time. In which machine? In M2. So it should be placed last. But since the last place has been taken over by A, we placed E as second last. So E here. Alright, and finally we are left with C. So C will be placed third. Alright, so there we are done with the sequencing B, D, C, E, and A. Now let's find out the total completion time. Okay, passing through machine M1 and M2. Alright, so which job will come first? Yes, obviously it's going to be B, and B is going to come down, it's going to enter at the 0 hour. It takes how much time? In M1 it takes 1 hour, so 1 hour. So after 1 hour it'll come down to, after 1 hour it'll come down to M2. Now as B is being processed in M2, which job will be processed in M1? D. D will be processed in M1. Alright, now how much time does D takes in M1? D takes 3 hours in M1. So 1 plus 3 is equal to 4. Now B, how much time does B take in M2? It takes 6 hours. So 1 plus 6 equal to 7. Alright, so this will be done by the 7th hour. So B will be done in M2 by the 7th hour. However, D is done in M1 by the 4th hour, right? 1 plus 3 is equal to 4. So obviously there will be some waiting time, idle time of how much? So 7 minus 4, there will be 3 hours of waiting time there. Alright. So once D is done with M1 by the 7th hour, it will come down to M2. Okay. And how much time does D take in M2? D takes 8 hours. Okay. And while D is being processed in M2, C will be processed in M1. And how much time does C take in M1? 9 hours. Okay. So 9 hours. So 7 plus 9 is equal to 16. Okay. 7 plus 9 is equal to 16. So by the 16th hour, it is done. Okay. So by the 16th hour, it is done in M1. And then by the 16th hour, it will come down to M2. Now you see here. Now there will be some idle time, you know where? In M2, because see, you know, because D is done. Alright, D is done by the 15th hour. 7 plus 8 is equal to 15, right? So D is done by the 15th hour. And C is going to come down to M2 by the 16th hour. So there's an idle time here of 1 hour. Alright. Okay. So C will come down by the 16th hour. It cannot come down in the 15th hour. Why? Because it will take 9 hours to be processed in M1 and it will be completed only by the 16th hour. So it can only come down to M2 by the 16th hour. So C takes, how long does C take in M2? It takes 7 hours. Okay. So 16 plus 7 is equal to 23. And as C is being processed in M2, E will be processed in M1. And how much time does E take in M1? 10 hours. So 16 plus 10 is 26. Right? So by the 26th hour it is done and it will come down to M2 by the 26th hour. However, C is done by what? By the 23rd hour it is done. Right? Because 16 plus 7 is equal to how much? 23. So it is done by the 23rd hour, but it has to wait. So it has to wait how long? 26 minus 23. So 3 hours it has to wait here. Okay. So there will be an idle time, not waiting time. Sorry, there will be an idle time of 3 hours. So no work happening for 3 hours. Okay. So E will come down from M1 to M2 by the 26th hour, and E takes how long? It takes about 4 hours. 4 hours in M2. So 26 plus 4 is 30. And as E is being processed in M2, A will be processed in M1. And how much time does A takes in M1? 5. So 26 plus 5 is equal to 26 plus 5 is equal to how much? 31. Alright. And here 26 plus 4 is equal to 30. So again there will be an idle time of 1 hour. 26 plus 4 is equal to 30. Okay. And A is going to come down to M2 by the 31st hour. A. So therefore there will be an idle time of 1 hour. And A takes how much time? Takes 2 hours. So 31 plus 2 is equal to 33. Alright, so the total completion time, the total completion time is equal to 33 hours, and the total idle time is equal to 3 plus 1, 4, 4 plus 3, that's 7, 7 plus 1, 8 hours. So there's an idle time of 8 hours. So this is how you solve a sequencing or prioritization problem using Johnson's rule.